Hello everyone, welcome to Geometry Today. This is Mr. Knowles speaking. For those of you that are in the Smart Courts class, since we're both gone today, we are sharing our workload as good teammates would do. He's working on a video for algebra, and I'm doing the geometry video today. Instead of stamping, we will stamp on Friday when you have your test, so 311 and 312. We'd also like to see 312, 313. That we probably won't stamp until Monday. So we'll stamp this during the test while you're working on that. And then we'll stamp that on Monday. Remember to finish the closure for extra credit if you want to. All right. Check your homework questions on its learning. And the individual test is on Friday. Make sure your toolkits are ready and that you are ready and that you have a calculator for Friday. Today, you and your team are going to work on 312 and 313. It's actually just 313 in the notes, but it's got some problems from 312 in it as well. You can see that even though we're not here, we still expect you to get plenty done. I'll help you with a couple, and then you guys should be able to work on the rest with your teams. So today's notes are about ratios of similarity. Yesterday we referred to them as zoom factors. We're going to learn how to use those a little bit better today. So we've already learned that when you enlarge or reduce a shape so that it remains similar, it maintains the same shape, each of the side lengths have been multiplied by a common zoom factor. You can also set up ratios within shapes and make comparisons to other similar shapes. Today you will learn about how changing the size of an object affects its perimeter. You'll also learn how ratios can help solve similarity problems when drawing the figures is not practical. So the perimeter problem you guys are going to work on. Bless me. You guys are going to work on in your teams. I actually want to get you started by looking at 15 together. So turn the page. Let's look at 15 together. So 14 you'll go back to. 15 we're going to start on together. This will help you with problems 13 and 14. Equal ratios of similarity. Casey wants to learn more about her enlarged C's. So again, that'll take you back to problem 313. But for this example, we can just look at the drawings that they have. The zoom factor multiplies each part of the original shape. So it multiplies each part the same. So the ratio of the width must equal the ratio of the length. Ratio is another term for zoom factor. It's the same thing. So when I look at these C's, and I'm comparing the lengths and the width, Casey decided to show these ratios in the diagram. Right. Verify that her ratios are equal. So when we compare the heights, we've got 24 over 8. When we compare the widths, we've got 18 over 6. There are a couple of different ways to compare this. One would just be, kind of going back to that comic from the beginning, if you didn't see it, here it is, proving that the fractions are equivalent, or that they're worth the same. One way we can do that is by looking at those fractions and saying, does 24 over 8 equal 18 over 6? If we reduce and simplify, we see that they both equal 3. So they are the same. Verify that her ratios are equal. So in this case, going from the small one to the big one, we see a zoom factor of 3. That's one way to reference this. But when looking at Casey's work, her brother wrote a different equation. 8 over 6 equals 24 over 18. Are his ratios in fact equal? Let's answer that question first. Are those ratios equal? Well, again, we want to reduce. So if I divide both of these by 2, I get 4/3. And if I divide both of these by 6, I also get 4/3. So they are equal. Here's the big question. How can he show this work in this diagram? What's another way to look at this problem? Well, if you see, how did he compare 8 to 6? He took the length and he compared it to the width. And then he took the length and compared it to the width. Notice that in both diagrams, the arrows connect similar things. Length to length, length to length, width to width, length to width, length to width. So it works the same in both shapes. This is another way that we can use a zoom factor. You can use the zoom factor within the shape itself and compare it to the other shape. So there's multiple different ways to do this. And so the last thing that I want to help you out with here is how do we do this when it's not so obvious, when it's not a zoom factor of 3 or a zoom factor of 3/4. So she decided to create an enlarged C for the door of her bedroom. To fit it, it needs to be 20 units tall. If X is the width of the C, write and solve the equation to find out how wide the C on Casey's door must be. Ready to share your equation and solution with the class. Really, you're just going to be sharing it with your teammates. So we can set up a couple different proportions. Proportions is when you have a ratio and a ratio together. So we could do what they did in the first one. 20 over 8 equals X over 6. Or we could do 8 over 6 equals 20 over X. How do we solve these? We solve these by cross multiplying. Cross multiplying. Watch what happens. Over here on the left, I get 120 equals 8x. And on the right, I also get 120 equals 8x. So both methods work. They both work equally well. When I divide 120 by 8, I will get what x is in both C's. I get x equals 15. So those are two ways to see these problems. There are lots of other ways to do these problems. You're going to have lots of opportunities to practice this skill set as you and your team complete these problems. So we've already done 15. 16, I'll have you check. You can check with another team, or you can check with the teacher in charge. They'll have an answer key as well. And then you can always check the rest of your answers. At the end, we will wrap up with a 5-minute closure. So you can pause the video here while teams work on 13, 14, 16, 24, 25, 26, and 28. And with 5 minutes left, we will close out the lesson and we can check all of our answers. All right, folks. Let's check where we're at. Hopefully your C's turned out to be like this. We can pause here so you can check your measurements. We already went through 15. 14, I'm just going to have you guys work, just double check with each other. We already went through 15. So here are some answers for 16. 16A, should have said no. These triangles are not similar because the zoom factor is not the same. 3 over 6, 4 over 7, 5 over 10. 4 over 7 does not match. The pentagons that right were similar. There's a couple different ways to do it. I looked at it 2 different ways. I said, well, the 8 and the 24 match up. The 8 and the 24 match up. So you could either divide by 3 or multiply by 3. To get y, I would divide by 3, and I get 6. To get x, I multiplied by 3, and I got 33. Again, we can pause here if we need to get this written down or fixed. 24, a couple different ways to do that. Hopefully you found one ratio 2 to 6 and 7 to 21. That's that one I did here. Those work. The other way would be with the black arrows, 2 to 7, which is not a super nice fraction, but it still works when you do 6 over 21 because it reduces down to 2 over 7. Lynn's problem in D was that she was doing it wrong. She was saying, okay, 2 over 7 this way, but then the arrow was going the other direction, 21 over 6. We can't mix up that direction. If you're going 2 over 7, you have to put 6 on top over 21. So they're not in the correct spots. Again, we can pause if we need to fix anything. Here are the answers for 25 as well. A couple of different methods I used, but hopefully you and your team found a method that works for you. In letter A, x is 12. In letter B, x is 8. And in letter C, x is 7. Notice I got that by taking my perimeter and splitting it up into 21 and 21. And so there's 18 left. Dividing that by 2, I get 99. Again, we can pause here if we need to copy anything. When we got to 26, Casey's back at it. Now she wants to enlarge block U. Long story short, when we do that, when we enlarge it by a ratio of 3 over 2 or 1.5, these are our new measurements. 3, 9, and 12, depending on where they are. When you add up the perimeters, you get 40 and 60. And when you find that ratio, you get that it is also 3 over 2. What a coincidence that the ratio of the perimeters, the side lengths, matches the ratio of the side lengths. Hint, hint. We're going to see this quite a bit more. We're going to continue with it. At this point, if you got this far, great. If not, make sure that you answer question 28 as well. And I'm going to leave that one for you guys to work on, area and perimeter. But I do want you to get out your toolkits and fill this in on your Chapter 3 toolkit, the yellow one. Some of you didn't get a chance to do this yesterday, so we can pause it right here, fill this in your toolkit. Our math notes and our homework 312, 313. If you didn't get a chance to pause it, I'll go back. You can pause it here, and the rest of the time will be yours. Have a good day. Test on Friday. Email myself or Mr. Marquardt if you have any questions before the test.